This video is meant to teach you or help you understand how factoring works with the distributive property. All right, so let's just start looking at some problems, and hopefully you'll make sense of what we're saying. You'll also remember it from class. So oftentimes we have these situations where there's a bunch of teams, right? So let's say there are 5 teams. Multiplication is going to mean for us groups of, right? 5 different groups of these teams, right? And say each team has 10 boys on it and it has 8 girls on it, right? So these are large teams. I don't know what they are. Maybe they're a soccer team or something. And I'll show you another way of thinking about that. When I say I wrote it as a multiplication problem, and we're multiplying this parentheses, right? We've got 2 numbers that we're multiplying, but you can kind of think of those parentheses as a team, right? So there's 10 boys plus 8 girls, that's one team. There's another team of 10 boys plus 8 girls, that's 2. Here's another team with 8 girls, oops, that's a G, right? And here's another team of 10 boys plus 8 girls. And finally, we have our 5th team, right? There's 5 teams. And if I added up the total of all the boys and all the girls, there would be 50 boys and there would be 40 girls. Okay? So that's basically repeated addition. I'm adding 2 different kinds of numbers, but what we're going to do is use the distributive property. We're not going to add 5 times. We're just going to multiply, right? What if I said there's 5 times 10 boys? Well, that would equal 50 boys. I'm going to change colors here. That would equal 50 boys, right? And now what I need to do with using the distributive property, I am going to distribute the multiplication across the parentheses, across the group. So I'm going to say there's also 5 groups of 8 girls. So that equals 40 girls, right? So that saved me having to add them over and over again. So that's called the distributive property, and you'll learn more about that in time. What we've been studying is factoring, right? So what we want to do is we want to try and take out a common factor, right? And in this case, our common factor is going to be 5. There's a larger common factor. It could be 10, right? But since we're talking about 5 teams here, let me show you what it looks like to take the factor back out, right? You're dividing 50 by 5, and you're dividing 40 by 5. Sometimes we call it double division, right? And what that means is if we take the factor of 5 out, it's going to go right back here, right? And we're going to write it as a multiplication or as a factor, right? So both of these could be factored by 5. And if I do that, it's basically saying I have 5 groups of, well, what do I have left? 50 divided by 5 is 10. That's 10 boys. And I have 8 girls left. 40 divided by 5 is 8 girls. That's what factoring is, right? This was the original way to express it, and we rewrote it as just an addition of the total, right? The total, you see it right down here. The total number of boys and girls. Once I multiplied those 5 groups, it gave me the total. And then what we're doing is factoring it out, right? So let's look at one more, right? Let's just say we have something like 12 plus, well, let me zoom out. Let me get a clean screen here, right? Let's say we have 12 plus 24. And I want to write this factored. I want to factor it and rewrite it. So I'm thinking the greatest common factor of 12 and 24 is, well, it's 12, isn't it? Right? So let's just factor out 6, right? 12 might be confusing. So what I'm doing is I'm dividing by 6, and I'm dividing this number by 6. And let's see what we get. I'm going to take those arrows out of there. That might be more confusing than it's worth. I'm going to say 6 is the greatest common factor. 12 divided by 6 leaves me 2. 24 divided by 6 leaves me 4. And there we go. We factored it out. Let me think of another one. Let's just take another random number. Let's try 18 plus, I don't know, 21. What's the greatest common factor of 18 and 21? Well, that's easy. 21 only has a couple factors, 3 and 7. Can 18 be divided by 3 or 7? Yes, 3. So let's take that 3 out, right? We're going to take it back out. 18 divided by 3 would leave me 6. 21 divided by 3 would leave me 7. And there it is. These two things are equal. Tell you what, I will put it back in, right? I'll show you. Let's multiply. So I forgot to write the multiplication sign there. It's not always necessary, but we put it there now so you know that that means multiplication. Let's put it back in. 3 times 6 equals 18. 3 times 7 equals 21. Right? So we're taking factors out and we're putting them back in. Dividing two numbers through double division, or multiplying two numbers through distributive property. Anyway, that's it.